Howdy everyone. Today we'll be going over integrals and basic trigonometry. So unfortunately, you're just gonna have to memorize them. Okay? That's just the fact of the matter. And here are a couple of rules that'll help you that you need to memorize at the end of the day. You're gonna have to sit down and do the dirty work. But there are some little tricks that I can teach you. So first, we need to memorize that secant x is 1 over cosine, and then cosecant is 1 over sine. And I remember always getting really confused on this just because, like, the secant and the cosine don't start with the same letter, and like the cosecant and the sine don't start with the same letter. And I think that was just bad design by whoever invented these words, right? But how I've learned to memorize it is that I just imagine the cosecant as so. So first, the sine, it reads like sin, right? And sin is bad. Let's just go with that, right? And if you notice, this in the cosecant, how I like to look at it is that the sin is being carried away by two bodyguards, as such. And then if you want to be really extra, you can imagine that the sin, the S, is actually a snake. So these two bodyguards are taking away the snake. And that's why we know it's related to sin, which means it's related to sine. So go ahead and use that if you wish, right? So let's go through these examples. So cosine x is going to be related to sine of x, right? And it goes the other way too. The antiderivative of sine of x is going to be cosine of x, right? Next, secant squared is tan x, okay? Cosecant squared is negative cotangent x. Now, again, because sine looks like sin, it just always wants to be a little bit special. The sine version is always a little extra, right? So when we're dealing with the sine version, just know it's going to be with the negative, and it's going to be with like the co-version. So instead of tangent, it's going to be cotangent, right? Okay. Next we have secant x times tan x is just secant x, right? It's just the same thing. And looking over here, because sine is always like wants to be a little bit extra, we notice that the cosecant needs the cotangent, not the tangent, the cotangent, and we're gonna add a little negative sign in the end. So really all you have to do is memorize the cosine side, and then just remember that like the sine always wants to be a little extra, and we just convert changes to cotangents, and we just tack on a negative sign. At least that's how I memorize it, you know? So let's go through some examples. So the examples are honestly going to be pretty straightforward. It's going to be, do you have them memorized, right? So in this first example, okay, we're going to first take sine of x, right? Okay, so the integral of sine of x is just going to be cosine of x, because we have that memorized. And then plus secant squared x. Now secant, this is the cosine one, so it's going to be like the normal kind. And I just have memorized that's tan x, right? And then we're going to tack on our plus c. And again, if you don't exactly remember, that's okay. It's back here. Take a screenshot, write it in your notes. We're going to be referencing this from now on. So here we have the sine one, and then the secant squared one is right there, right? But sometimes it's not going to be as straightforward. So in this case, if like sine over cosine x or squared, like we don't have that anywhere on our list. But it's a trick, guys. It's all a trick. It looks weird, but we can make it look not weird, right? And that's just going to take some extra manipulation. So in this case, we're just going to separate out the two cosines as so. And notice how this is still comes out to cosine squared, right? And if we do some more trigonometry, 1 over cosine x, well, that's just secant. And then sine over cosine x, that's just tangent. And do we have a rule with secant and tangent? Indeed we do. We have it right here. And we know that's just secant. And we don't forget our plus c. We don't forget our plus c, guys. Okay, let's work with this third example, right? We have 1 over sine x times 1 over sine x. I'm going to go ahead and bring out the 2 because I don't want to worry about it at all. And then I'm going to combine these two signs into one, right? That's going to be sine squared x dx. Correct? And we know that the inverse of sine is the one with the little bodyguards, right? So co-CSC x dx squared. And do we have a rule for that? Indeed we do. But it's cosecant, so that won't relate to sine, so it's going to be a little weird. So it's probably going to be negative, and a cotangent might be involved. And indeed it is. It's being a little special snowflake. And so we have a negative sign and a cotangent. And we don't forget the plus c. And there we go. That's trigonometry and integrals. I hope you have a great day.